Google has introduced EmbeddingGemma. This is the best-in-class open model for on-device embeddings. So this particular 308 million parameter embedding model delivers best-in-class performance for its size. So you can actually deploy this locally, right? So this particular model is the highest ranking open multilingual text embedding model, 500 million parameters on the Massive Text Embedding Benchmark. It is based on the Gemma 3 architecture. This is trained on 100 plus languages and is small enough to run on less than 200 MB of RAM with quantization. So this is actually excellent model for on-device AI to do on-device applications like on-device RAG, right? So you can use this Gemma embedding Gemma basically for this. Now this particular model is small, fast and efficient. It also offers customizable output dimensions from 768 to 128 via Matryoshka representation. So this means that you can have variable dimensions embeddings from the same model. So if you feel that 128 vector, basically 128 bit vector embedding is good for you, then you can go for 128. You can also go up to 768. So you have various output dimensions available, right? And this has a 2K token context window. So it can run on everyday devices like mobile phones, laptops, desktops, and more. And this is designed to work with Gemma 3N, so you can unlock new use cases for mobile RAG pipeline, semantic search, and more. They also have integration with tools such as sentence transformers, llama.cpp, MLX, Ollama, transformers.js, LMStudio, Weaviate, Cloudflare, LlamaIndex, LangChain, and more. Okay, so this is an exciting release from Google, right? So EmbeddingGemma generates embeddings which are numerical representation, in this case of text, such as sentences and documents, by transforming it into a vector numbers to represent meaning in a higher dimensional space. So this is general explanation of what are textual embeddings. The better the embeddings, the better the representation of language with all its nuances and complexities. Okay, so they've given an example over here of this. So while you are building a RAG pipeline, you have two key stages, which is retrieving relevant context based on users' input and generating answers grounded on that context. Now for the first step, to perform retrieval, you actually need to store your documents in a vector database. Okay, so where you will use embeddings, right? Now this is where this embeddings will come into the picture, and this helps you to actually embed your text in a very good manner, whereby when you have a query, you are trying to find out what is the relevant content from the vector database and retrieve that relevant content. So for RAG pipeline to effective, the quality of this initial retrieval step is critical. So poor embeddings will retrieve irrelevant documents, leading to inaccurate or nonsensical answers. This is where you require high quality embeddings like EmbeddingGemma, which provides the high quality representations need to power accurate and reliable on-device applications. Okay. So what they are saying is that this model is particularly has strong performance on multilingual embedding generation. So here is a comparison between EmbeddingGemma and other models of similar size on the MTEB benchmark. Okay, and here you can see that this has class leading performance. Okay, it is small, fast and efficient. Same thing which they are telling. Okay, it's composed of roughly 100 million model parameters and 200 million embedding parameters. This 308 million parameter model. You have this Matryoshka representation learning, so you can have various dimensions of vectors. You can have 128, 256, or 512 or 768 dimensional vectors, right? And what they're saying is that this has less than 15 milliseconds embedding inference time on 256 input tokens, right, on HTPU. And you can also do quantization aware training, whereby you can reduce RAM usage to sub 200 megabytes while preserving the model's quality. So you can, because it's a very small model, you can use it for offline purposes. Okay. That is what they are saying over here. You can use it for private or sensitive user data, right? Because you can have the model on the device. It need not be on the cloud. So it is built for on-device flexible and privacy-centric applications. Now they have these notebooks, right, which you can go and try out on how to use this Gemma embedding model. Okay, it's embedding Gemma model, not Gemma embedding, right? So here they've explained how to do it, right? You install all the packages, you load the language model, which is text generation Gemma 3. So here you are loading the embedding model using the sentence transformers, right? So this is how you load this embedding Gemma over here. And then they explain how you can do RAG with this particular model, right? Simple RAG example, they've given some documents over here, and then they use this embeddings to actually, generate similarities and other things. So you can check out this particular notebook. You can run it on Collab, right? And it is very simple to run this in Collab, and you can understand how you can create RAG applications with this particular embedding. And here they are using, for the generation part of the text, they are using, right, Gemma 3B. Gemma 3 4 billion instruction tuned model over here. So this is a simple tutorial for how you can do RAG with embedding Gemma. If you want to fine tune embedding Gemma on your domain, there is this Collab notebook, right, whereby you can fine tune this embedding Gemma on a particular notebook, on a particular domain, basically, right, for your use cases. So here, the most important thing is actually creating a fine tuning data set. So they've explained that part over here as like, okay, the data often should be triplets, the original query or sentence. There is a positive sentence, which is very semantic, similar to the original sentence or anchor. And there should be a negative sentence that is a related topic, but semantically distinct. So you need this prepared triplets, okay, with these three sentences of anchor, positive and negative, to actually fine tune the embeddings. So everything is explained over here. You can check out this particular notebook also to fine tune the embedding Gemma on your domain data. Okay, that's the idea over here. So both the notebook also are provided over here. So what else are they saying over here? The main use cases for on-device offline use cases, right? So this model is very good for your best choice for privacy, speed, and efficiency. But if you are looking at large-scale server-side applications, you can look at Gemini embedding model. Okay. So, and you can download the models on Hugging Face, Kaggle, Vertex AI. They have provided you with documentation, inference, and fine-tuning guides, which is these notebooks. You can check that out. So this is an exciting development from Google, embedding Gemma. Okay. So you can try out these embeddings for your RAG pipelines for on-device AI. Hope this video on embedding Gemma is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.